everyone told you Einstein was wrong, that he was a stubborn old man who couldn't accept the future of physics. But here's what they didn't tell you. 50 years after his death, experiments proved he was right. And what he was right about should terrify you. Einstein spent the last 30 years of his life fighting quantum mechanics, the most successful theory in the history of science. Every other physicist thought he'd lost his mind. But Einstein kept saying the same thing. This theory is incomplete. Something is missing. Reality doesn't work this way. What was Einstein seeing that every other genius missed? And why, when physicists finally did the experiment he demanded, did the results shake the foundations of reality so badly that the implications still haven't been fully accepted today? In this video, I'll show you exactly what Einstein saw, why quantum mechanics genuinely disturbed him, and the experiment that confirmed his deepest fear, that reality, at its most fundamental level, is nothing like what you experience. Here's the irony: Einstein helped create quantum mechanics. In 1905, his paper on the photoelectric effect proved that light comes in discrete packets called photons. That paper won him the Nobel Prize. It was one of the founding acts of quantum theory. But then quantum mechanics grew into something Einstein could not accept. The theory claimed that particles don't have definite positions or speeds until you measure them. Before measurement, an electron exists in multiple places simultaneously. Reality, according to quantum mechanics, is fundamentally probabilistic. Nothing is certain until observed. Einstein found this deeply wrong. His objection wasn't religious or emotional, it was scientific. He believed physics must describe an objective reality, a reality that exists whether or not anyone is looking. A moon doesn't stop existing when nobody looks at it. Reality can't depend on the observer. For 2 decades, Einstein debated Niels Bohr, the father of quantum mechanics, at physics conferences across Europe. Einstein would invent a thought experiment designed to break quantum theory. Bohr would find a flaw overnight. It happened again and again. The physics world watched, stunned, as the 2 greatest minds of the century went to war. In 1935, Einstein fired his most powerful shot. Working with 2 colleagues, Podolsky and Rosen, he published a paper that appeared to prove quantum mechanics was incomplete. It became known as the EPR paradox, and it introduced the world to one of the strangest phenomena in all of physics: entanglement. Entanglement is this: create 2 particles together, then separate them, one on Earth, one on the other side of the galaxy. Measure one particle, and the other instantly reflects that measurement. Not after light speed delay, instantly. No signal travels between them. Einstein called this spooky action at a distance and said it proved quantum mechanics must be wrong. Einstein's position was not that quantum mechanics was useless, it was spectacularly good at predicting experimental results. His argument was that it was incomplete. He believed hidden variables existed, information we couldn't yet access that would restore determinism and remove the need for spooky action. The randomness wasn't real, it was just ignorance. In 1964, Irish physicist John Bell did something remarkable. He turned Einstein's philosophical argument into a testable mathematical prediction. Bell proved that if Einstein's hidden variables existed, experiments on entangled particles would have to obey a specific statistical limit. If quantum mechanics was right, that limit would be violated. Finally, after 30 years, the argument could be settled by experiment. In 1982, French physicist Alain ran the definitive experiment. He created entangled photons and measured them with detectors that switched their settings randomly, fast enough that no signal could possibly pass between them. The results were unambiguous. Bell's limit was violated. Quantum mechanics won. Einstein's hidden variables were ruled out. Aspect's work was so significant that in 2022, he shared the Nobel Prize in Physics for it, along with John Clauser and Anton Zeilinger. The Nobel Committee's citation confirmed it explicitly. Local hidden variables do not exist. Einstein was wrong about the solution, but here's the twist: he may have been right about the problem. Einstein lost the battle over hidden variables, but he was pointing at something real, something that the experiments confirmed even while proving him wrong. The universe is non-local. 2 entangled particles separated by any distance behave as if they are one object. Space, in a meaningful sense, does not separate them. Non-locality means that reality at its deepest level is not made of separate objects sitting in space influencing each other. It's made of connections. The separateness you see, this table, that wall, you and me, may be a large-scale illusion built on top of a reality where everything is fundamentally entangled with everything else. This is exactly why physicists still can't find a theory of everything. Einstein spent his final decades trying to unify gravity with quantum mechanics. He failed. Every physicist since has also failed. The reason may be exactly what Einstein sensed, that quantum mechanics as currently written is still missing something fundamental about the nature of reality and space. And here's the psychology angle that makes this even more disturbing. There's a phenomenon called the illusory truth effect. The more you hear something repeated, the more true it feels, regardless of evidence. Physicists repeated Einstein was wrong for decades. It became an axiom, but the experiments showed he was wrong about the answer, not about the question. Which brings us to the deepest question buried in all of this. If separateness is an illusion, if every particle you're made of is entangled with particles across the universe, then what are you? Where do you end and everything else begins? Does the concept of an individual even make sense at the quantum level? Most working physicists today adopt what's called the shut up and calculate approach. Use quantum mechanics, it works perfectly, don't ask what it means about reality. Einstein would have found this intellectually cowardly. He believed physics had an obligation to describe what is actually real, not just predict measurements. Cosmological perturbation theory, the study of how tiny quantum fluctuations in the early universe became the galaxies and structures we see today, depends entirely on quantum mechanics being correct. The large-scale structure of the universe itself is a quantum phenomenon. The trillions of galaxies you see in telescope images, their locations were decided by quantum randomness moments after the Big Bang. Einstein's real legacy isn't E equals mc squared. It isn't even relativity. It's the question he refused to stop asking. What is reality actually made of? Not what does the math predict, what is actually there? 50 years after his death, that question still doesn't have a clean answer, and that is exactly what he warned would happen. So here's where we land. Einstein didn't lose. He identified the deepest crack in physics, the one that still hasn't been repaired. The experiment proved reality is non-local, entangled, and fundamentally strange in exactly the way he feared. He was right about what was wrong. He just couldn't tell us what was right instead. But this raises one question I couldn't answer here. If hidden variables don't exist and the universe is genuinely random, then free will, determinism, and the nature of cause and effect all need to be completely rethought. That rabbit hole goes much deeper than you expect. I'll take you there next time. Before you go, do you think Einstein was fundamentally right that quantum mechanics is incomplete? Or do you think reality is genuinely as strange as the math says? Comment below. The most interesting answers will be featured in my Subscriber Theories video.